Good day everyone, I'm Kelly of metric number 157371 from group M9B with two lab partners of Sufi and Naziha. First of all, I would like to talk about the methodology for this experiment. This experiment is divided into two parts. The first part, part A. At first, we need to set up the apparatus as shown in this diagram, and we need to place the steel ball on the striker. Next, we need to pull the firing spring to the first tension stage. And also, we need to adjust the ballistic unit to 25 degrees. And after this, we need to release the steel ball, record the display speed, which can be displayed on the small screen, and the maximum height being achieved by using a meter ruler, and also the range being recorded by the steel ball by using a meter ruler also. Next, we need to repeat the above steps with second and third tension stages. And finally, we need to repeat the whole experiment by changing the degree into 35 degree, 45 degree, 55 degree, and finally 65 degree. For part B, it is similar to part A, but we need to adjust the ballistic unit to 45 degree and record the display speed and also the range being recorded by the steel ball. Repeat the above steps also by varying the stages into second and third stages. Next, I would like to start with the first question in this Viva. For question A, what do you think is the best angle of projection to start the experiment with? In my opinion, I think that 45 degree is the best angle of projection to start the projectile experiment, because for 45 degree, the projectile motion can have a longer maximal horizontal distance, or we can call as range. For part B, suggest a way to accurately measure the height of projection of the steel ball in this experiment. I suggest we should use the apparatus of stroboscope because it can record the slow motion of the whole projectile motion, and also it is easily for us to trace the height of the projection and the pattern of the whole projectile motion. For part C, suggest a way to determine the time taken for the projectile in this experiment to measure the maximum height. So we can use the equation of V equals to U plus AT, where V should be 0 because when the steel ball achieves the maximum height, the final velocity should be 0, and the U will be the initial speed for the projectile motion, and A will be the gravitational acceleration, and T will be the time taken for the projectile motion in order to achieve the maximum height in the projectile. Let's continue with question D. From the theoretical physics point of view, will the type of material of the ball affect the range and height of projection? Why and why not? In my opinion, from the theoretical physics point of view, the type of material of the ball will not affect the range and height of projection, because the range and height of projection are independent of the material of the ball, but instead the initial velocity and the time of flight are the two factors which will affect the range and the height of projection. Next, for the last question, part E. If your answer to question 3D was yes, state whether steel or wooden ball would give more accurate results and explain your answer. If your answer to question 3D was no, explain why in the real experiments performed, there are still significant discrepancy in the range and height of projection obtained using steel and wooden ball. In my opinion, the existence of significant discrepancies in the projection experiment is due to the existence of random errors like F movement, which will bring about the existence of air resistance. As we all know, the effect of air resistance depends on the shape and also the velocity of the ball being projected. And the velocity of the steel and wooden ball will affected by the air resistance, which will bring a large impact on the whole motion of the projectile motion. Hence, this will bring about a significant discrepancy in the range and height of projection, because the small changes in the velocity will bring about the large difference in the range and also the height for the projectile motion. Okay, I think that's all for my presentation. Thank you so much.